Section 013 is on representing data. We're going to look at several different ways to represent some of this data that we've been looking at in the previous section. First one we're going to take a look at is called a frequency table. It's a table that uses tally marks to record the frequencies of events. And then a bar graph is a visual representation of the frequencies of the values. So here's an example from your textbook I'd like to take a look at. So it says make a bar graph to display the data, and we have 4 different sports, and I would presume that this is the number of people that play each sport or maybe the number of games in the season. Oh, actually here it is, it's favorite sport, it's labeled over here. So so this is the table, the frequency table, and here is the bar graph that represents that. Notice that it has a title, favorite sport, otherwise you wouldn't know what it was. And the axes are labeled. So on the vertical axis we have the number of students for whom this is their favorite sport, and then across the horizontal axis across the bottom here we have the name of the sport: basketball, football, soccer, or baseball. So you'll see that for 15 people that were interviewed, basketball is their favorite sport, so we draw a bar that goes up to the number 15. For football it was 25, soccer 18, and baseball 21. And it doesn't have to be super exact, but you do need to have these delineations on your axis here. And notice that there is a space between the bars. So that's a frequency table and a bar graph. Cumulative frequency for an event is the sum of its frequency and the frequency of all previous events. And a histogram is a bar graph that represents data in intervals. So here's an example from your textbook. Okay, so here we have the age of inauguration and the number of U.S. presidents that were that age. So for example, what this means in this table is that there were 2 U.S. presidents who were between the ages of 40 and 44 when they became president. There were 7 presidents between the ages of 45 and 49, and so on. So to make a histogram of that is going to look like this first graph here. Again, we have a title, ages of presidents. We have our axes labeled, so across the bottom here we have age at inauguration, and we have those intervals that are given there, 40 to 44, 45 to 49, and so on. And then on our vertical axis we have the number of presidents. So since there were 2 presidents ages 40 to 44, we draw the little bar up just to number 2. Because there were 7 presidents between the ages of 45 and 49, we draw the bar up to 7, and so on for the other categories. And you'll notice the difference here between this histogram and the bar graph is that there are no spaces between the bars here. Okay, if you're drawing this, you don't have to color it in, but you do need to have little lines between them so we can see the difference. Now, a cumulative frequency histogram is going to add up all of the previous values. So for example, we had 2 presidents whose ages were less than 45. And then we had 2 plus 7 or 9 presidents whose ages were less than 50. Let's go back to this chart up above here. You'll notice that if we're looking at ages less than 50, so those that fall in this 45 to 49 category and those that fall in this 40 to 44 category, there are 9 presidents who were less than 50 years old when they became president. And then if you jump up to the next category, you're going to have 22, or 2 plus 7 plus 13 presidents who were less than 55 years old when they became president. So that's represented in this table here. So less than 45 is 2, less than 50 is 9, less than 55 is 22, and so on. And then those are the values that are graphed in this cumulative frequency histogram. So now notice this one says the cumulative ages of presidents, number of presidents again on the vertical, and age at inauguration on the horizontal. But notice this time it's going to be these values in the top box here: less than 45, less than 50, less than 55. So we have had 44 presidents, and I don't know the time range. Yeah, that could be for everything. 44 presidents who have been less than 70 years old when they became president. Let's draw one of these ourselves. So this table here shows the ages of volunteers at a local animal shelter. We need to make a histogram and a cumulative frequency histogram of the data. So we have 6 volunteers who are between the ages of 16 and 25, 4 volunteers between 26 and 35, and so on. So in order to, so this is the data that we would put into a regular histogram, but let's go ahead and figure out the data that we're going to put into a cumulative frequency histogram. So again, we'll have the ages, and then we'll have the number of volunteers, but this time we're not going to break it down into these categories. I'm going to say how many are less than or equal to 25, and that's going to be 6. Now I'm going to go up to the next category. How many are less than or equal to 35? And that's going to be the sum of these two here, because the number that are less than or equal to 35 would be everybody in the second category and everybody in this first category, or 10. And then less than or equal to 45 is going to be 6 plus 4 plus 9, or 19. Less than or equal to 55, I'm going to add 12 to that number for 31. And less than or equal to 65, and that's actually going to be the total of how many total volunteers I have here, or adding 8 to 31, which is 39. Now when I go to draw these histograms, here's what they're going to look like. Animal shelter volunteers, here I have the number of volunteers and then the categories of their ages, and then because in this first chart I had 6 volunteers that were between 16 and 25, I go up a little bit past 5 to 6 for the 6 volunteers there. In the next category, 26 to 35, I had 4, so that's what this bar here represents, and so on. And then you'll notice in my cumulative, and actually I probably should have written the word cumulative above this one, cumulative animal shelter volunteers, notice now I'm graphing by category, so those that are less than 25, and that's going to be 6, less than 35 goes up to 10, less than 45 goes up to 19, and so on. So your cumulative frequency histogram is always going to kind of look like it's going upwards. The bars are going to be getting bigger. A line graph is another sort of graph that's useful for showing how data changes over time. And here's an example from your textbook. So here are the sales at the Marshall High School school store. So in September, they sold $670 worth of merchandise, October $229, and so on. So again, you're going to have your horizontal axes, in this case, by the month. So we have the months labeled. My vertical axis is going to be the sales in hundreds of dollars, or they have hundreds there, but then dollars. And then I put a point for each value. So in September it was 670. So in September my dot here represents about $670. October 229. So that's right here. And then the rest of the dots here, and then you go ahead and connect those with a line. This is very useful for seeing how things change over time, because this absolutely makes sense that the sales at the school store would be very high in September when school starts. Everybody needs their supplies and their sweatshirts. And then it kind of drops off. And then you actually have another peak here around maybe around February or March. Maybe the weather's getting colder and people need to buy some more sweatshirts or something. And then it kind of drops off. And then you actually see that they don't even have anything graphed for June, July, and August when school is not in session. A stem and leaf plot is a T-chart of data values in which the leaves are the digits of the smallest place value and the stems are the remaining digits. So let's do one of these together. We need to make a stem and leaf plot of the following data. So I'm going to make a little T-chart, and I'm going to label this stem. And these are going to be my leaves. Just label it leaf. Okay, and I'm looking at my data, and I don't actually have to line it up, but I'm seeing that my smallest value seems to be like 2, and my largest is probably 41. So my largest place value is the tens, so that's what I'm going to put here. So I'll have 0 tens, and that's going to represent my single digit numbers, and then 10s, 20s, 30s, and 40s. And now I just need to list the leaves. So in other words, if these are my tens, these are going to be my ones place values. So I actually have 3 2s in the chart. So there's a 2, there's a 2, and there's a 2. So I need 2, 2, 2. And I'm looking for single digit numbers. I think I have 3 3s. So that's going to be a 3, a 3, and a 3. And then I have a 4, a 5. Do I just have one 5? No, I think I have 2 5s. And single digits left, I have a 9 and another 9. Extend that out so it looks nice. Now I'm going for my 2-digit numbers and the ones that start with a 1. So I actually have a 10, so that's going to be a 0 here because that's going to be 1, 10, and 0 1s. And then I have an 11, just put a 1 for that. I have a 12, and I think I have 2 15s. There's a 15, and there's another 15, so that's going to be 2 5s. Then I have a 16, that's a 6. I have a 17, that's a 7, and I have an 18, that's an 8. And those are all of my 2-digit numbers that start with a 1. Now let's go for those that are in the 20s range. And I have a 20, that's going to be a 0. I have a 22, that's a 2, and a 23, that's a 3. Now my 30s, I have a 35 and a 38, so that's going to be a 5 and an 8. And then my remaining one is a 41, which will be a 1 right here. The other thing I need to do is I need to create a key for this, and I'll put this down here. I need to tell people, what does this mean? In other words, what place value is my stem and my leaves? So if I have, and you can just pick any number in here, so 3, and then put that slash, that's like this vertical line here, and a 5, that means that refers to the number 35, so people understand what you mean there. Another type of way of representing data is with a circle graph, or sometimes called a pie chart. And this shows the relationship between the whole and the parts of the data. So let's do an example together here. This table shows that how the Astronomy Club raised $500. So the sources of their fundraising. So at a car wash, they raised $125. At a fish fry, they raised $150. At a game-a-thon, they raised $75. And through poster sales, they saved $150. And that total, raised $150, that total is $500. So I need to figure out what fraction of the circle, or how many degrees of a total circle, each one of these sources of income represents. So to do that, I'm going to have to pull out my calculator and do a little math here. So $125 out of the total of $500 they raised, that's equal to, and just punch that into your calculator, 0.25, or 25%. Now I'm going to say, what is that 25% of the 360 degrees that are in a total circle? And that means 90 degrees. So I need 90 degrees of my circle to represent the car wash money that they raised. And I'll do the same thing for the rest of these. So $150 on a fish fry out of 500. That is 0.3, or 30%. So I need to calculate what is 30% of my total 360 degrees in the circle, or that's 108 degrees. The game-a-thon raised $75 out of the $500, and that is 15%, or 15% of 360 is, what is that, 54 degrees of the circle. And 150, I already did that one up here, but I'll just go ahead and fill it in. So $150 on poster sales, that's 30%, or 30% times 360 is another 108 degree segment. Now at this point you need to pull out a protractor, and I'll have some protractors in class. And when you draw your circle, it's going to look something like this. Notice that this does have a title, Astronomy Club Fundraising, and then this is your 90 degree segment right here. Poster sales was 108 degrees. this was 108 degrees, and this was 54 degrees. And so it's a really good way to look at it and say, oh, they made the least amount of money through their game-a-thon, but they made the same amount of money and the greatest amount of money through their fish fry and poster sales. And the last one we're going to take a look at is called a box and whisker plot. This is a graphical representation of the 5-number summary. The box in the box and whisker plot is going to represent the IQR. So let's do one of these together. Let's make a box and whisker plot for the following data. And then we're going to need to describe how the outliers affect the quartile points. So the first thing we want to do is line up this data in order, since we're going to be looking for the 5-number summary. So I have an 8, 13, 14, 2 16s, 2 18s, 2 20s, a 22, and a 30. Okay, so let's find our median here. So I have 2, 4, 6, 8, 10, 11 data values. So the one that's going to be in the middle is this one right here. There's my median. And let's find our quartiles. So looking at the lower half, this is the median of the lower half of the data, so that's going to be my Q1, my lower quartile. And then in my upper, this is going to be my Q3, my upper quartile. And here I have my minimum. And then here I have my maximum. Okay, but what we first need to do is figure out if we have any outliers. So you remember, to do that, we're going to calculate the IQR, the interquartile range, which is the difference between Q3 and Q1. So Q3 minus Q1 is going to be 20 minus 14, or 6. That's my interquartile range. And now let me give myself a little more room here. To see if we have any outliers, I'm going to take my Q1 and subtract this from it. So I'm going to do Q1 minus my IQR, which is going to be 14. Oh, I'm sorry, not my IQR. I need to, sorry, forgot about that. I need to calculate what is 1.5 times my IQR. That's right, that's the way it works. So 1.5 times 6 is 9. So, oh, sorry about that. So my first lower quartile minus 1.5 of the IQR is going to be 14 minus 9, which is 5. So, and then let's do the Q3 plus 1.5 of the IQR, or that's going to be 20 plus 9, or 29. So what that means is that anything that is less than 5 or greater than 29 is an outlier. So that means that my value of 30 is actually an outlier, because that is greater than 29. Okay, now that we have all that data, now we can actually draw our box and whisker plot. So to do that, I'm going to do a number line, and this would be easily done on graph paper because you'll have some, actually have some marks you can use. And I'm going to go by 2s here, just to bear with me while I keep drawing this a little bit here. Like I said, this would be a lot easier on graph paper because you've already got the boxes. And I'm going to make this go just a little bit longer, I think. Probably should have gotten rid of that. Okay, so my box is going to be the interquartile range. So I actually, let's get my numbers here. My Q1 was at 14. My median was at 18. My Q3 was at 20. And my minimum was 8. And my maximum was 30. But remember, 30 was an outlier, so my maximum without the outlier is 22, so I'm going to mark that one there. Now we're going to draw a box between these values here. Draw a line through there, so there's my box. And then my whiskers are these lines that go out to my max without the outlier and to my minimum. Okay, so this is what your box and whisker plot is going to look like, and I believe it said describe how the outliers affect the quartile points. Okay, so when we emit the outlier, let's take a look at that. So omitting the outlier, okay, then I have my data values 8, 13, 14, 16, 16, 2 18s, 2 20s, and a 22. So now my median at this point is going to be right in between here. So my median is now 17. My Q1 is 14, which it was before. And my Q3 is 20, which it was before. And now my min is 88 and my max is 22. My IQR for this is still 6 as it was before. So when I omit the outlier, it decreases my median from 18, see my original median was 18, to 17, but does not change the first quartile, the third quartile, or the IQR. So let's go ahead and write that out. So omitting the outlier, decreases the median from 18 to 17. But does not change either my lower quartile or my upper quartile. So this was kind of a long section because we looked at a lot of different ways to represent data, whether with a box and whisker plot, a circle graph, a stem and leaf plot, line graph, histogram, cumulative frequency histogram, all sorts of different ways to represent data, but it's very important to see a visual representation. It kind of helps you understand a little more what's really going on with the data.